Hello, my research is about collective perception, and our approach is a distributed postgraph optimization. In collective perception, cars share their perceived information with each other in vehicle-to-vehicle communication platform. Using this way, they can have more accurate perception since we have redundancy in the perceived data, so we can have sensor fusion. And the fleet also can have a better perception coverage since they can see further and they can see the blind spots. For example, the pedestrian coming into the road here, and the yellow car don't see the pedestrian, but the other cars are seeing the person and can tell the yellow car in advance. In multi-robot localization or alignment, we define the pose of the robot at different time steps as the vertices, and the differences of these poses as the edges. We have two kinds of edges: intra-robot measurements, or the odometry information are defined as these edges, as you can see, and we can have inter-robot measurements, which is the relative pose measurement between two different robots. And our goal is to minimize the error of the whole graph using some smoothing and mapping approaches. Usually this is done in a central manner, but for collective perception in collective driving, we have some privacy and implementation issues. So we are interested in distributed postgraph optimization. We have less privacy concerns since we are not sharing all the information with the others. And in the studied approaches, we are going to see its accuracy is at the same level of the central approaches. In order to do this in the literature, there have been a proposed method named two-step distributed Gauss-Seidel approaches, which is using chordal initialization method. And as you can see, our goal is to minimize this distance function in the two-step approach. First, we minimize this term and then minimize the complete term. For the experiments, we have annotated data captured from a public camera, and as you can see, we have the bounding boxes, the IDs, and you can see the connections here among the cars, and so using this way we are going to simulate collective perception, and we are also doing the sensor noise simulation this way, and then we are going to optimize using both central and distributed approach. As you can see, the results for distributed methods are at the same level of for both two-stage and central optimization approach are at the same level. For conclusion, using chordal initialization in distributed postgraph optimization, we can implement collective perception for the alignment of cars on the road. By this way, we don't need a central server, and we communicate as less information as possible in the collective perception, which is good. This approach is robust to disconnection and is almost at the same accuracy level as the central vehicle alignment approaches. This study could be strengthened using more realistic simulators and more data and higher number of vehicles. Here are the references. I'm ready for your questions. Thanks for your attention.